Hey everyone, welcome to our second trig lesson. Today we're going to be talking about reference numbers. Your aim is how do we use reference numbers to find terminal points. So terminal points is what we talked about in the previous lesson on the unit circle. Homework number 14 is going to be on a handout of the old textbook. It's going to be numbers 37 to 50. So actually that's the entire page. I'll just Xerox those questions. So yeah, just complete the entire page. But your objectives are going to be understand what a reference number on the unit circle represents. Second, use reference numbers to find terminal points. Third, know what coterminal means. Okay. All right, here's your do now. So find the terminal point determined by A, t equals -7 pi over 6, and B, t equals -4 pi over 3. Okay, so as you can see, we're going to be using radians a lot in this unit. Okay, so please, if you're not comfortable with it now, this is a very good class to get comfortable with radians, and it'll be necessary, as I said before, for calculus. Okay. All right. So I actually won't be going to the slide for this. This is I'm going to actually try drawing the diagrams here. Okay, so -7 pi over 6. If you think about that, so pi over 6 is 30 degrees, right? 180 divided by 6 is 30. And then 30 times 7 is 210, right? And then we have to make it negative. So since it's negative though, it's going to be clockwise. So -210, we're going to go in this direction. It's going to end up like right around here. Okay, so this is quadrant 2, in other words. Okay, so that's -7 pi over 6. And then -4 pi over 3, let me draw that here. So -4 pi over 3, pi over 3 is 60. All right, so 180 divided by 3 is 60. And then 60 times 4 is 240, so it'll be negative 240. So -180 is this part, and then another 60 left over. So we'll still be in quadrant 2. That, let me move down to the answers. Okay, so -7 pi over 6. So again, we're in quadrant 2. The angle here is going to be 30 degrees, right? Because we did -210, so it's going to be 180 and then another 30. So 30 degrees here, okay? Now, at this point, you just have to think, what's cosine 30 and what's sine 30? And then we'll adjust based on the quadrant. Okay, so cosine 30 is radical 3 over 2. Okay, that's right here. And then sine of 30 is 1/2. Okay, sine of 30 is 1/2, so that'll be, now since we're in quadrant 2, cosine will be negative, right? Because the x-coordinate here in quadrant 2, any quadrant 2 coordinate is going to be negative, so it's going to be -3 over 2. And the y-coordinate is going to be positive 1/2. Okay, so there you have it. That's your answer for part A. Part B, we have -240. So the angle here is going to be 60 degrees. Okay, so 180 and then another 60. Okay, so cosine of 60 is 1/2. Sine of 60 is √3 over 2. And quadrant 2, right, the x-coordinate is negative, y-coordinate is positive. Okay, so that'll be your answer for part B. -1/2, comma, √3 over 2. I was trying to get rid of the drawings here. All right, sorry about that. Back to the lesson. All right, so here's a definition for today. It's going to be reference number. And then we're going to follow up with some examples. And next is going to be the algorithm or the procedure to find terminal points using reference numbers. And then lastly, we have another example. Two examples. And then the worksheet. Okay. All right, so let me get to the slide for the first definition. That's your homework. Okay, here we go. So let t be a real number. The reference number t bar. Okay, so t bar associated with t is the shortest distance along the unit circle between the terminal point determined by t and the x-axis. Okay, so the shortest distance along the unit circle between the terminal point determined by t and the x-axis. So let me draw a diagram to show you what that means. So let's say you have like a t value here, right? We're going counterclockwise, assuming it's positive. So here's your t value. Okay, so some arbitrary t. Shortest distance along the unit circle between the terminal point determined by t and the x-axis. So in this case, it would actually just be, this looks like around like pi over 4. So t bar is actually the same thing as t, right? So it's the shortest distance between the terminal point here and the x-axis. Okay. Now this isn't very interesting. It's interesting if you like go into the second quadrant. So let's say you have a t of, let's say 135 degrees. Okay. So that means this angle will be 45 degrees, and t bar here is going to be 45 degrees. Okay, so here t bar is, all right, pi over 4, right? Pi over 4, 45 degrees. Okay, pi over 4. Okay, but t was equal to 3 pi over 4. Okay, but t bar is pi over 4 because t bar, the reference number, is the shortest distance along the unit circle between this terminal point here and the x-axis. Okay, so always with respect to the x-axis. So if you need to copy this, or if you need more time to copy this, please pause the video here. Otherwise, I'll move on to the example here. Okay. So I'm going to jump up to the solution for that. All right, so our job is to find the reference number for each value of t. First, t value is 5 pi over 6. Okay, so before I write the diagram, it's always helpful to convert it to degrees first, so that you can get more of a sense, since we're more familiar with degrees. So yeah, that'll give you a sense of like where it should be. So 5 pi over 6 is 150 degrees, right? So pi over 6, that's 30. 30 times 5 is 150. That's how we get that. And then the reference number is going to be from the shortest distance between the terminal point and the x-axis. So 150 degrees, that would be in the second quadrant, but let me draw that here. And that reference number is going to be pi over 6 here. But yeah, let me draw for you. So that's second quadrant, right over here. Okay, so 150 degrees, so 90, and then another, 60 degrees? That'll place us here. So the reference number here is pi over 6, or 30 degrees. Okay. Next, we have 7 pi over 4. Pi over 4 is 45. 45 times 7. So I don't expect you to like know that, but you can see that it'll be like 45, 45, 7 times, right? 1, 2, 3, 4, 5, 6, 7. Okay, so this is 180 plus another 90, that's 270. And 270 plus another 45, that's 315. Okay, so let me draw that here. That'll be right over here. Okay. Right. But yeah, it'll be 360 minus 315. That's one way to calculate the reference number. But yeah, as you can see, the angle here between this terminal point and the x-axis is 45 degrees. Okay, that's pi over 4. Lastly, we have negative 2 pi over 3. So negative 2 pi over 3, that's negative 120, right? Pi over 3 is 60. 60 times 2 is 120. So it'll be negative 120. Negative 120 is clockwise, so we'll go this way. And this angle, right, 120. So to get to the x-axis, to complete like this 180 here, we need 60 degrees more. Okay, so 120 plus another 60 would bring us to the x-axis. So therefore, the reference number is going to be pi over 3. Okay. All right, if you need the answers here, please pause the video here. Otherwise, I'll be moving on to the next set of notes. All right. All right, so this is just an algorithm for how to find the terminal point determined by t. You might already, intuit this, like you might know this already intuitively. But yeah, if it's helpful for you, here's the algorithm. Step 1, find the reference number t bar, which we did in the previous example. So that's how you would do it. Step 2, find the terminal point AB determined by t bar. Okay, so yeah, just find the sine of, so the cosine and the sine of that, and then that'll be the x and y coordinates respectively. And then you just have to adjust for the sign. So step 3, the terminal point determined by t is plus or minus a, comma, plus or minus b, where the signs are chosen according to the quadrant in which this terminal point lies. Okay, so find the reference number, and then determine the terminal point for that reference number, and then adjust for the quadrant that it's in, okay? And that'll tell you the sign. All right, if you need to copy this down, please pause the video here. Otherwise, I'll move on to the next few examples. All right. All right, so here we are. So here's our first one. Find the terminal point determined by each given real number t. So these are actually part A, B, and C. These are actually the same numbers that we just solved in the last example, right? So 5 pi over 6, 7 pi over 4, negative 2 pi over 3. Same numbers. Okay, so we actually know the t bar is pi over 6 for part A. So the terminal point determined by pi over 6, right? So cosine of pi over 6 or cosine 30 is root 3 over 2. Sine of 30 is 1/2, okay? And then we just have to adjust for the quadrant. And as we know, 5 pi over 6, right? So pi over 6 is 30. 30 times 5 is 150. So that'll be in second quadrant, right? That'll be over here, right? 150 degrees. So yeah, I write quadrant 2 here. So x coordinate is negative here in this quadrant, y coordinate is positive. So here's our final answer, negative root 3 over 2, comma 1/2. All right, next part is part B, 7 pi over 4. T bar is pi over 4. All right, so these should be your answers from the last example. I won't be going through it again, but yeah, just reference your notes for that. And what do you call it? Let me erase that. Sorry, see a typo here. Okay, so T bar is pi over 4. And at this point, just ask yourself, what is cosine of pi over 4? What is sine of pi over 4? Cosine of pi over 4, or cosine of 45 degrees, is root 2 over 2. Same thing for sine, right? Sine pi over 4 is root 2 over 2. And this is going to be in quadrant 4, right? So 7 pi over 4, that's 315. That'd be in this quadrant. Okay, so x coordinate is positive here, y coordinate is negative, so it'll be root 2 over 2, comma, negative root 2 over 2. Okay, that's your answer to part B. So quadrant 4, yeah, root 2 over 2, comma, negative root 2 over 2. All right, next we have negative 2 pi over 3. The reference number we got for that was pi over 3. And cosine of pi over 3, or cosine 60, is 1/2. Sine 60 is negative, sorry, not negative, root 3 over 2. So 1/2, comma, root 3 over 2. And this is going to be in quadrant 3, right? So negative 2 pi over 3, that's negative 120. So clockwise for negative angles, that'll be right here. And as we can see, right, the x coordinate is negative and the y coordinate is negative. Okay, so quadrant 3, it'll be negative 1/2, negative root 3 over 2. Okay, so these are your 3 answers right here. All right, if you need that solution, please pause the video here. Otherwise, I'll be moving on to the next one. All right, last question before the classwork. So this question has to do with finding the terminal point for large t. And by large t, we just mean like anything over like 1 full revolution, anything over 360 degrees. Okay, so here's our example. Find the terminal point determined by t equals 55 pi over 6. And the way we're going to do this is we're going to subtract full rotations from this, because as we know, right, if you take away 360 degrees, you're going to end up at the same location, right? So if you take away multiples of 360 degrees, you're still going to end up at the same location. Okay, so that's the concept that we're going to use to solve this question. Okay, so t equals 55 pi over 6. And I'm going to subtract full rotations from 55 pi over 6. Okay, now here you just have to be mindful of the denominator. The denominator here is 6, right? So to get a full rotation for 6, the numerator will be 12 pi over 6. Okay, and the reason for that, you can see that as if you reduce, right? So 12 pi over 6 is 2 pi, right? So 12 divided by 6 is 2, right? So this is 12 pi over 6 is the same thing as 2 pi, but we're just being mindful of the denominator here. Okay, so 12 pi over 6 is 2 pi. And we're going to multiply that by 4. Okay. in order to get as close as possible to 55 pi over 6, right? So 12 times 4 is 12, 24, 36, 48, right? So that's as close as we can get without going over. So this is 48 pi over 6 plus, we have 7 left over to get to 55, right? 48 plus 7 will get us to 55. So 12 pi over 6 times 4 plus 7 pi over 6 is equal to 55 pi over 6. Okay. And here I explain 12 pi over 6 is equal to 2 pi, which is full rotation. And if we just ignore this, so here 12 pi over 6 times 4, so this is just 4 full rotations. So we can just ignore that, right? Because if we just take that away, so to speak, then we're going to end up at the same location. So the only number we have to be mindful of here is 7 pi over 6. Okay. And here I write that, note that 7 pi over 6 is coterminal to 55 pi over 6. And what I mean by that is they share the same terminal point. So in other words, they're at the same location. Okay, so in other words, we just find the reference number for 7 pi over 6. And 7 pi over 6 is going to be equal to, well, pi over 6 is 30, and then 30 times 7 is 210, right? So if you draw that here, 210 degrees, that'll be, this is 180, and then here's another 30. So this would be quadrant 3, and the reference number is 30 degrees, right? 180 plus another 30. And if you notice, if this is, so actually this is a tip, if this is fully reduced, right, you can just ignore the coefficient here. So you can ignore 7, and then pi over 6 is going to be your reference number. As long as it's fully reduced, that works, right? Okay, but anyways, we had to find the reference number for, oh, sorry, I didn't mean to do that. We had to find the reference number for 7 pi over 6, which is pi over 6. And then at this point, find cosine of pi over 6 and sine pi over 6. Well, cosine of pi over 6 or cosine 30 is root 3 over 2. Sine of 30 is 1/2. Okay. And so because it's in quadrant 3, the x coordinate and the y coordinate are both going to be negative. So your final answer here is going to be negative root 3 over 2, comma, negative 1/2. Okay. Final answer right here. All right. If you need this solution, please pause the video here. Otherwise, I'll move on to our classwork solutions. So here's our classwork. So the first question was in a table. Okay, and we just have to complete the following table. The answers in red here are what you wouldn't see on the worksheet, right? But this is what you would see. So the t-value here is going to be that negative 33 pi over 2. And yeah, let me break that down for you. So this is a large t, right? It's over 360 degrees. So I break that down, negative 33 pi over 2, by, subtracting full rotations. Okay, but because this is negative, I'm gonna, instead of doing positive 2 pi, I'm gonna do negative 2 pi. Right, negative 2 pi and 2 pi are, full rotations, just in different directions, right? Negative 2 pi is gonna be clockwise instead of counterclockwise. Okay, so negative 4 pi over 2, right? That's the full rotation. And then we're gonna multiply that by 8 to get as close as possible to 33 pi. Okay, so here we have negative 32 pi over 2. And then we need to subtract another pi over 2 in order to get to negative 33 pi over 2. Okay, so in other words, we just ignore this part, right? Those are full rotations. We're just spinning our wheels there. So we just have to be mindful of this one. So pay attention to that. So this is coterminal, in other words, with negative pi over 2. Okay, so negative pi over 2 and negative 33 pi over 2 are coterminal. Okay, let me draw that angle here. So negative pi over 2, that's negative 90. That's right over here. Okay, so you can see that it's going to be it's on the negative y-axis. So the coordinate here is going to be 0, comma, negative 1. Okay, so let me go up to that solution here. So the first row here is going to be, right, the reference number is pi over 2, right? And it's going to be negative y-axis, and then the terminal point is 0, comma, negative 1. Okay, all right, so that's your first row. Second row is 55 pi over 4. So that'll be 8 pi over 4 times 6, right? That's the closest we can get. So 8 times 6 is 48. And then we need another 7 pi over 4. Okay, so we just calculate for this. 7 pi over 4, that's 315 degrees. Okay, that's in quadrant 4. here. Okay, quadrant 4. Okay, and the reference number is pi over 4. Okay, all right, with that in mind, quadrant 4, reference number pi over 4. Let me jump up here. So here's the reference number pi over 4, quadrant 4, and then it's going to be cosine of 45, sine of 45. Adjust for the signs though. So cosine of 45 is root 2 over 2, sine of 45 is root 2 over 2. But since it's quadrant 4, the y coordinate is negative, x coordinate is positive. Okay, that'll be your answer for this. All right. Next question is 48 pi over 6. So this actually hasn't been reduced. So we actually have to, just simplify, right? So 48 divided by 6 is 8, right? So this is the same thing as 8 pi, which is easy enough, thankfully. This is the same thing as 2 pi times 4 plus 0. So in other words, this is coterminal with 0, okay? And as you can see here, the reference number I write here is 0. It's on the positive y-axis, the positive x-axis. And the terminal point would be 1, 0. Okay. All right, lastly for this table, we have 16 pi over 3. And full rotation for that denominator would be 6 pi over 3. So 6 times 2 is the closest we can get. That'll be 12. And then we need to add another 4 in to get 16 pi over 3. Okay, so we just ignore this part. Those are full rotations. And we calculate the reference number for 4 pi over 3. So 4 pi over 3. Pi over 3 is 60. So 60 times 4 is 240, right? So 180 and then another 60. Okay, so it's quadrant 3, as you can see here. All right, so the reference number is pi over 3, right? It's 60 degrees here, quadrant 3. And then cosine of 60 degrees is 1/2. Sine of 60 is root 3 over 2. But since it's quadrant 3, both of these are negative. Okay. All right, let me jump up to the table for you in case you need to copy it. But yeah, here is your solution to the table. So these are your answers here. Pause the video here if you need these. And let me scroll down to the work. And here's the work for how we got the answers in the table. Okay. All right, last but not least, we have question number 2. Find the terminal point determined by t equals 29 pi over 6. Okay, so this is another large t question. And yeah, just remember, we're going to subtract full rotations. So 12 times 2 is 24 pi over 6. So 24 pi over 6, we need 5 more, right? So we have 5 pi over 6. So 5 pi over 6 is what we actually need to take care of, right? So 5 pi over 6, well, pi over 6 is 30 degrees. And then 5 pi over 6, that'll be 150, right? So 150 degrees, that's in quadrant 2, right over here. Reference number is going to be pi over 6, right? So this is 150, and then another 30 to get to the x-axis, okay? All right, so t bar is pi over 6, and then the terminal point is going to be, the coordinates of that are going to be root 3 over 2, 1/2, right? So cosine of 30 degrees is root 3 over 2, sine 30 is 1/2. But since it's in quadrant 2, this is going to be now negative x coordinate, positive y coordinate. So it's negative root 3 over 2, 1/2, and that'll be your final answer. Okay. If you need this solution, please pause the video here. But yes, I believe that is all for today. And yeah, here's a visual of your homework. But yeah, that's all I wanted to say. And I'll see you all in the next lesson. And take care. Let me know if you have any questions in our synchronous Zoom session. But yeah, I'll see you all soon.